Budapest office. We have 10 other offices across the world. The Budapest people, most of the people here in the Budapest office joined through an acquisition. So we used to be Distinction. I'm one of the co-founder, and we joined Skyscanner approximately a year ago. Currently, we have 35 people, 36 maybe, in this Budapest office, and more than 700 all across the world. We are working on mobile apps, so basically this office is just about mobile development. We have 6 squads working on Skyscanner products, which is used by 50 million people every month. So we have a significant user base so this is both web and mobile. We have around 40 million downloads so far on both Android and iOS. So that's Skyscanner. To be honest, I haven't seen so many native developers here in Budapest so far, so I'm really glad to see this amount of people. So we'll have 3 very interesting topics today, one iOS, one .NET, and one Kotlin. I hope you guys will enjoy, and I will be around during the presentation as well as after the presentation, so feel free to contact me if you have any question. And the only thing is that you have to enjoy and ask questions later on. Thank you very much.
Hi, welcome everyone, and I will be really short. So we will start with David from Supercharge, and he will tell you about how they are reusing code in Supercharge.
Basically, that's it. Thank you. So, hello everyone. My name is David Kovács. I am the CTO of Supercharge, and today I will talk to you about one of our recent projects where we've had to develop a state-of-the-art telco self-care application and ship it to several countries. So, what's the concept behind this and how we've reused most of our code? So, the basic is that we have a telco self-care application with a core feature set, and we need to develop this as a core product and customize it to country-specific needs and ship it to different countries. So first I will talk to you a little bit more about these self-care applications and what are the basic features, what we need to customize. I will talk to you about the challenges that we faced along the way, and then I will show you the iOS-specific solutions we've come up with, but I'm sure if you are an Android or a Windows Phone developer, you will be able to switch out the libraries and concepts we used. And at the end, I will talk a little bit about testing, continuous integration, and how the teams are collaborated on the core code, and a little bit about the releases at the end. So, what's a self-care telco application? It's basically where you can manage all your contracts, your bills, pay your bills. Obviously, it has a login and authentication functionality. There's a dashboard. After the login, you can see here your most important data about your mobile plans. You can manage your contracts from the application. You can turn on or off services, get extra data boosts, get roaming services, and this kind of stuff. Obviously, you can manage your bills from here. You can pay your bills, you can see your payment history, you can see statistics about your bills and stuff like this. And obviously there are other parts, payment, store locator, telecom apps, other telecom apps. So there are a lot of core features in this one application. And what are the differences between the countries? So in every country we have a different backend system. There are SOAP-based backends, there are RESTful backends, there are some backends that seem RESTful but they are actually not. So there are different kinds of backends. We have different kinds of login and authentication mechanism. We have different payment provider in every country. We have different type of contracts, different type of users, and obviously localization, unit formatting, data formatting. These are all country specific. So basically we need to be able to customize anything inside the application. So we have the core feature set, but we need to customize anything that the country needs. So let's see it from the implementation point of view, what we really need to customize. So first, the user interface. This is the most obvious one. We need to be able to replace wall screen flows with the business logic behind it, or sometimes we need to only switch out one screen, or only switch out one part of the screen. So this is from the user interface point of view. Obviously, as I said, we have different backend systems in every country, so the wall integration parts needs to be easily replaceable. We need to have different type of network communication. We need to have different type of business logic behind the core features. So we need to customize those as well. And last but not least, the localization, translations, unit formatting, data formatting, price formatting, all of these are country specific. So we have these requirements. So what architecture should we choose? We've been experimenting with different kinds of MVC-like architectures like MVP, MVVM, and Viper in the last couple of years, but we couldn't find one that fits all of the application needs. And most of the time we felt that these architectures tie your hands quite a bit. So you need to build separate objects and separate classes for every layer, and sometimes there's just too much and you feel that you are doing this just because of the architecture and not because you really need them. So we went with a pretty lean and basic architecture. I'm finding the laser pointer. Okay, so you can see here that we have separated the code into modules. So we have dashboard module, contracts module, payment module, billing module. So we have a module for every bigger functionality or every bigger feature. And you can see here with the gray background the codes that are in the core project, and you can see the code with orange what's in the country-specific project. So as I've told before, the data managers and the network layer is always country-specific, so that's in the country-specific projects. And all the other stuff, data manager interface, the UI components, the presenters, those are in the core module. And obviously when you need to replace some UI or some originally some stuff that's originally located in the core code, then you can switch those as well. So, how should we structure our project? We've seen a lot of kind of project structuring lately. You could have different projects and different artifacts for the features, or you can have it by layers. But we went with a quite lean approach here as well, with only having one project for the core code that's developed as a pod. And we have a core example project, what actually is a mocked version of the whole core application. So you can try out and you can go through all the screen flows, you can try out the app, but in the background everything is mocked, so there is no network communication. And this is located in the core repository. In the country-specific repository, you have the country project, what actually the implementation of the data managers, the implementation of all the country-specific stuff, the custom UI components, and all the others, and it's tied to one version of that core development code. Okay, so how we are replacing any object of the application for the specific countries. This is the major part of this full approach. We are using dependency injection everywhere, basically. So in iOS, the Typhoon framework is the obvious choice. It's quite mature, it has a lot of features, and it almost handles every use case that you would need from a dependency injection framework. It has this assembly structure, or the assembly-like structure. Basically, you have an assembly for every module what you have. So we have a billing assembly, an assembly for the contracts, etc. We've moved every object initialization to these assemblies, from the app delegate to all the view controllers. It can integrate with the storyboard as well, so it can automatically initialize your view controllers. And these assemblies can be overridden in the country-specific implementation. So if you need to replace one object in your code, you just replace or you just override that initialization function in the assembly, and that class will be replaced with your country-specific implementation all over the application. So here you can see this automatic injection on code level. So you just say that, or you just declare that you need a protocol and building data manager with a building data manager interface, and when you initialize this object, it will be filled out automatically. So you don't have to do anything with your hand. Okay, so we can now replace any object in our application. How we are replacing a part of the screen. On iOS, this is quite tricky because you have your views embedded in each other. So if you want to switch out just one part of the screen, you need to somehow find that view, remove it, and then put something in place of that. So it's not that easy. That's why we've came up with this kind of view architecture. You can see here that we are building up every screen from components. They are so this is one component, this is one component, this is one component, this is one component, and these components are embedded in a component collection. That's actually the whole screen, and these components obviously are aligned with auto layout, with constraints. The width of these components are defined by the screen's width, so it can fit to any kind of screen size, and the height of these components are defined by the inner constraints of these components. So this is how actually our screens are built up. So we have these components. These components can be inserted, deleted, or replaced on each screen. You can see here an insertion of a component. You just register this component to the component collection, and then it will put every component below each other, and they will be aligned with constraints. These components are independent from each other, totally, so they are not communicating directly with each other. They are communicating through the data managers. So if one component selects something, it does it to the data manager, and then that other component can use it from the data manager. Okay, so how we are selecting different features for these country-specific projects. So we have this core concept. We have a lot of features developed in the core, but obviously sometimes we don't need some specific features in the country applications or in the country-specific applications. So we've introduced feature flags. These are a little bit different. These are called business feature flags. They are a little bit different than the release feature flags, what are used for managing feature rollouts. These are, so every main feature has a feature flag in the application, and they can be turned on or off in the country-specific implementation. Actually, you can see here the concept. They are managed on the UI level, so we basically turn on our component or turn off, and then it will be in the screen or it will not be in the screen. And you have to be careful with these feature flags, because unlike the ones used for release, these will stay in your application forever. So that's why you have to minimize their usage. You have to minimize their usage to the UI level, because it adds branching and it adds plus logic into your code, so it complicates it. You can have more bugs, and you can imagine. So yeah, keep the feature flags on the UI level, and also write tests against them. So I've gathered some best practices, what does not fit in the above, what we felt good in this concept. So most of the time when you are writing a code, you try to put everything as private, so no one can access it from outside. But in these kind of applications, it's much better approach to put everything to public. So in the country-specific implementation, everyone can alter its usage. So all IB outlets should be public, all component attributes should be public. So because if someone just wants to change a small thing like hide a button in the country-specific implementation, then he just needs to subclass the original one and then hide that one button. But if it's declared in your implementation file, then he will not be able to access that attribute. And obviously, you should have a staging and production environment for your applications. For easier testing and maintenance, you should have build scheme, and it should be handled by build schemes. It's much easier if you have one configuration file with all of your configurations per environment, so you don't have to look for configuration variables around your code. So yeah, these are some best practices. Okay, and a little bit about testing. We have two different kinds of tests in our app. This first one is mainly for the core code base. These are called snapshot tests. Actually, this FB snapshot test case library is developed by Facebook. It works like you are initializing your view or your component. You take a snapshot of your component, and then that snapshot will be compared to a saved one. And if it's like a pixel by pixel comparison, and if there's a difference between the two pictures, then your test will fail. If there isn't any difference between the snapshot pictures, then it will pass. So here you can see that we are testing feature flag. So it's a quite complicated case when you have two feature flags correlating to each other, and we've set both to false. It's actually injected by the dependency injection framework, so you don't have to do anything else than just to mock these functions and then initialize your view, and then you can have this comparison with this heavily snapshot named function, and everything is taken care by this FB snapshot test case framework or library. And the other type of tests are mainly located in the country-specific implementation. These are the integration tests we've used. We've used two kinds of approaches here. One is what you can see here with this NSURL connection VCR library. This is a quite handy library. You can record your network communication, and then that network communication will be played back next time you run your tests. So you don't have to wait for the actual real network communication to happen, and when you have a large responsive from the servers, then you don't need to embed them to your test code either. So this is actually done in the background automatically by this VCR library. But of course, if you want to test some edge cases like network errors or HTTP error responses, then you can use Notchilla or other type of HTTP mocking libraries, what makes it easier. And a little bit about continuous integration. We've used Jenkins for our whole continuous integration process. Our workflow was to create a merge request in our GitLab repository control. This merge request will be merged to the main development branch, and then some automatic code analysis tool will run, like OC style, to check the code against our coding style, OC lint to check some to check for some linter errors, and then we run all of our automatic tests. If everything goes well, then it will be released to Fabric, and anyone can, or the QA can, reach the release and QA it. And if everything went well again, then the merge request will be marked as mergeable, and then someone will review that code, and if still everything is okay, then it goes to the development branch. So, about the collaboration and versioning. Currently there are two teams working on the core per mobile platform. So, two teams are working on this iOS core. The communication is done via Slack. It's happened to be pretty important because we can talk the new features and the changes with each other, so we can be sure that no one will collide on the core code and no one will break anything on each other's country-specific release. Yeah, this is not probably the best way, but this is still the one we could come up with, and it's working pretty well. Collaboration on the core is through Fabric, through GitLab with merge requests. We have a changelog where we log all of the changes in the core. So if someone needs to upgrade to a new version of the core, then he can just check the changelog and check what could be broken, possibly, or what should be not. Documentation for the core features. Actually, we don't have too much, but this should be handy for selecting the new features for the new country-specific releases. And the core is versioned with semantic versioning, so we have a major, a minor, and the patch version. So this is how we can make sure that when we are upgrading to a new core version, then there will be no incompatible changes, or there will be only bug fixes in this version. And the production releases are handled by the separately by the teams. So this is not coordinated by the core. So what's the summary here? I think you should find and you should use a simple and flexible architecture, but you should stick to that. So you should not alter from that architecture, because that only complicates things. You should have a really flexible UI. This is really key. So you don't have to replace wall screen flows or wall screens, then you only need to replace one button or add one button to your project. Continuous integration is really important, and communication is key between the collaborating teams, so the core can be developed as an integrated part and not some separate branches. After the meetup, you will be able to download the presentations. So here are the references I've been talking about. There are a lot of libraries here what we've been using, so you can check those out. And thanks. So, anyone have any question? Yes?
So do you use any kind of storyboard stuff?
Actually, we've used one in one module, but then I think we've dropped that completely.
Yeah, good choice.
Yeah. So we are not using storyboards. We are using only SIBs for every component, every different component.
We are using storyboards, but only like a SIB, like only one view in the storyboard.
Yeah. basically that's the way.
But how does it integrate to your system?
So actually, when the storyboard is initiated, then it's initiated or it's initialized from Typhoon. And when the view controllers are initialized inside the storyboard, then Typhoon takes care of that, and it can inject your dependencies inside your view controllers. Yeah, but you only have to have your app delegate initialized by Typhoon, and then you can have your whole application integrated. Yes, there was a question for
Yeah. How do you handle the integration between the core module and between the country-specific builds? Like you're building in a separate parallel mode. So one we're working on the core and working on the country-specific builds. Like integration between the actual development phase or actual latest stable, or the whole combination of these, the development stable.
Yeah, actually it's a kind of a combination. We are developing new features and we version the core in the semantic versioning. So if someone uses, for example, 3.1.0, then they just upgrade the patch releases, and the integration is basically one big data manager interface. This integration part. And if someone adds a new function, for example, to the integration, then it will be a new major release version, and then the other team can check what changed, and then he can implement that new function.
I have another question. How many country builds or country teams do you have?
Currently, there are 3 countries developed on the iOS version with this one core. Yes?
Yeah, what's the advantage of having 2 teams on each platform?
Sorry, I couldn't.
What's the advantage of having 2 teams on each platform? 2 independent teams, rather than having 1?
Yeah, actually it was a risk management from the client, so it was kind of a risk management choice to have 2 different teams. Yes.
You mentioned that you are using modules. So what are modules in your case? Are these like separate projects or just separate parts of the?
No, they are only separate parts of one project. So we have only one project, and we have these modules in that one project. But they are just separated by folder, nothing else.
Yeah, just a question. Do you have an Android version? And if yes, do you use a similar architecture for the coding design?
Yes, we have an Android release and we have almost the same design there. Actually, only the UI architecture is a little bit different, but the other stuff are pretty much the same. We have Dagger there for this dependency injection part, and yeah, but the others are quite the same.
Yeah.
Okay, so if you don't have any other question, thank you again.
So, our next speaker is Mate from Skyscanner, and he will actually convince you to use Kotlin instead of Java for Android.
Hi guys, I'm Mate from Android, from Skyscanner, and I'm an Android developer here. Actually, I'm an Android developer just for 1 year. Before that, I was a C# developer, and that time I thought C# is the best language I will ever come across. But then I found Kotlin, and I got so excited. So I want to share some thoughts about this beautiful language with you. So why would we even want to replace Java? I don't think I have to talk about this that much. So basically the new Java has some very cool features like lambdas and stuff like that, stream support, but Android is not there yet. It's somewhere between Java 6 and 7, and there are some 7 features, but not everything. And there are some workarounds for these issues. For example, the time library, datetime library backport, retro lambda, RxJava, and stuff like that. But we can't avoid all the issues around Java. Everybody who writes or reads Java see that it's not expressive, it's really verbose. You have to check everything for null, and when you're doing, you still get numerous null pointer exception every now and then. And you have to use thousands of utils, and it doesn't really support functional programming, just with some anonymous classes, but it's not that expressive. So, about Kotlin, it's basically a JVM language, so it compiles to Java bytecode. It is developed by JetBrains. It's named after an island which is near St. Petersburg. There they are developing Kotlin. The development started in 2010, and the first public release was in 2011. So it's a pretty new language, and the current version is almost the final one. It's 1.00 beta 2.422, but the final release should be out this year or early next year. So why would you choose Kotlin when we have so many JVM languages like Scala, Groovy, and stuff like that? Thankfully, Jake Wharton did this job for us and created a really great documentation and some measurements around these libraries and features. So as you can see here, Kotlin is really has really a small footprint compared to Scala or Groovy. The library size is really small, so your application won't be large, and also method count is really small compared to the others. And also with these JVM languages there are some issues. So you either have some dynamic type system, and reflection is really slow on Android, and the Scala is really good, but it's really hard to use together with Java. So basically, if you want to write Scala, you have to rewrite your whole application, or at least it's not that convenient. And Kotlin has all these fancy features and has a small footprint, which is necessary for Android development. So I'm not going to talk about how you set up Kotlin for Android development, because there are a lot of tutorials on the web, so you can just find one and set it up for Android Studio. It's pretty simple. So I'm just going to go through some basic functionality of the language, see how much better is it than Java's. So how do we implement a basic data class, an immutable data class in Java, which has some equal support and toString method? That's it basically. It's a person class with 3 fields and equality comparison and the toString method, and also getters and setters. So that's not that, less code. Yeah, so I was like basically this guy when I first saw it. This is just a single data class, and this is how it looks like in Kotlin. And actually this does a lot more, but here I will pause for a little and just let's look for some syntax here. So basically there is a specific class called data class, which is an immutable class type in Kotlin, and you also have a primary constructor, but you can define secondary ones. You don't have to create actual properties or fields, because the video val and var keyword it's already defined in the constructor, and also it supports default values, not like Java 6 or yeah. I think Java 8 supports it. Yeah. And what does it does to us? Basically the same we have seen before, equals and hash code. It provides a default two-string implementation. Also, it has multi-declaration support, which is really great stuff when you, for example, want to iterate through maps and you just want the key and value and don't want to bother with complex classes. And also it provides a copy method, which is really powerful here. So you just deep copy this immutable object. Well, it's not deep, but it's immutable, so it can be shallow. And you just tell which property you want to change, and it will be changed. So basically, in all Java, you can do this like clone, modifying this property, clone, modifying that property, and stuff like that. So you basically have to create a method for all the properties you want to alter in your cloned object. The other essential stuff for functional programming is lambda expressions. A lot of languages support it, but not Java and Android. Java 8 support this. Basically, there is a filter method here, and this is how you implement it. It's really basic, and you can see the filter function in the method properties. And how you use it, you just give a predicate, which is an anonymous class in Java, and it takes about 8 lines of code to write this item, and starts with predicates. So it's much powerful and easier to read. So for example, if you have code reviews, it's much easier to look through with these lambda functions than the anonymous classes. Also, you can inline these lambdas, which is really powerful because you don't have to generate these anonymous class instances every time you are using them and then call for the GC. So inline is a really powerful feature of Kotlin to make it more performant. Extension functions are basically they are just syntactic sugar, but it's really powerful to read and use. It is really convenient compared to Java util classes because you can extend the class basically without having to alter its code. At least syntactically, you do that. So let's see the same filter implementation we have seen before. You can here see for every generic iterable type, you can call this filter as if this method was inside the class, and give it a lambda, and then you can use it as if it has been written into the class itself. And the same sample of how to use it. So you just call the filter on the list object. So the other great feature of Kotlin, which is really bad around in Java, is how do you handle null values. Even Android API provide a lot of objects which has a meaningful null value. The other bunch of objects don't have a very valid state of null, but you either have to null check all the time. So, for example, if you want to get a property out of a object chain, you have to write numerous null checks, or else it will just throw a null pointer exception somewhere. And the same code in Kotlin. So this is not big magic. It's supported by a lot of new languages like C#. And there are null-safe operators basically which make it possible. There is null propagation here, so if anything is null through the code, through the chain, the outcome will be null as well. But you don't have to check it for all the time. You just have to handle the null exception at the end of the code by returning null or returning default value or whatever. The else operator is used for that. You have to replace the null value with some meaningful default. But this is not the real good thing about Kotlin, but the real deal is that you actually don't have nullable values by default. So every type in Kotlin is not null by default, and you have to write that mark after every object to make it nullable. So for example, you can't write the first line, but you can write the second. The real powerful thing about it is that you actually have compile time checking. How do you handle null? And if you have meaningful null values, you have to handle it explicitly, so you won't have null pointer exceptions runtime. And if you don't need that null value, you just don't define it, and you don't have to handle it afterwards. Not like in Java, for example, when you can simply make a string not nullable. So you will have to define. You will have to null check it all the time, or maybe it will throw null pointer exceptions. Another really great feature, which is really deep, so I'm not gonna go into the details, but let's think about it as anonymous extension methods. So you can actually have a lambda over a type, and you can reach that type's member variables, and it's used for when you want to implement builders in a typeset builders actually, and it has really great syntax, and it's useful for a lot of things. For example, let's check this apply method. This is the implementation. The actual data after the T generic type shows that this is not just a single lambda, but an extension lambda. And after using the apply after person, which is basically a new object, you can set its value. And you don't have to reference the person itself, because in the block you can reach the person's inner methods and properties like it was defined in the scope. And there are a lot more features about Kotlin, but I don't really have time to go through all of them. They are syntactic sugar and a lot of cool features. Generic is really convenient using Kotlin. It's similar to C#'s generic system. It's declaration side orients, which is not the case with Java, but it's not that powerful, so you have to handle the generic type in the same manner as Java. So you will have to pass with the method to get the actual generic information of the class. Yeah, really great feature of Kotlin that you can easily mix it with Java. So you don't have to rewrite all your application. You can just start to implement some library or a new page or whatever in Kotlin, and you can just mix it with Java really easily. For this, Kotlin uses a lot of sugar again, like what is a getter and a setter in Java. It's a property in Kotlin and vice versa, so you don't have to take care about those. Also, what is a static, a so-called static, so object in Kotlin is a singleton or mapped static in Java and vice versa. The only issue here is that by mixing code, you won't have this cool null safe system. So if you call, for example, Kotlin code from Java, you won't know that this string is actually not null, so you will have to null check, even if even if it's not null, because you defined it like in Kotlin. And if you do the other way, you can't actually think that. So if you have a Java object into Kotlin, you won't know that it's not null, so you have to think that it can be null, because there is nothing like this not null type in Java. You can control how things map to Java code with these GVM annotations. So, for example, for the extension methods, you can define how to name the util class for Java to use it. So, for example, if you create extension methods in Kotlin, it will be a something util in Java, and then you just can use it as in the old ways. Yeah, basically that's it. And for Android development especially, there are some libraries for Android developers. One is developed by JetBrains. It's a Kotlin Android extension. It's basically a property delegate code generator for the activities and fragments, so you can reach the views in a very convenient way. It basically generates a simple caching into each fragment and activity, and an extension property, and then you can reach all your views as if they were defined as properties in your activity and fragment without having to add any code. And Kotlin does it for all your layout XMLs, and you have just to import the correct one into your activity and fragment. Yeah, the Anko is a really big library. It actually has a lot of Android-specific features, but the most important is the type-safe builder for the Android UI. I'm talk a little bit about it. So, if you don't like XML as I don't like it and want to write the layout from code, it's a really powerful way to do that, because you can do anything what you can do in XML, but you can do a lot more, like instantly attaching your listeners to the view, and it's just basically a method call, so you can replicate it, merge it with other layouts easily, and it's much more powerful, and I think it's easier to read as well, but it depends on your favor. And it's also easy to be extended with your own views, custom views, and any other custom attributes or properties that you can define with your own Android views. And actually Anko has intent builders and asynchronous task helpers and a lot of helping extension lambdas for toast and logging and stuff like that. So why don't we use Kotlin? This is a really interesting question, and I think we should use it definitely, but there are some technical debts here. So it increased the application size and method counts obviously, but it's not that big that it should be an issue. Bigger problem is that it's still beta and has breaking changes every now and then, but it should be final in any time, so that won't be an issue again. There are several Java libraries which are a bit harder to use with Kotlin because of some limitations around the syntax. It can be used, it's just not really convenient, and sometimes it needs coding around. For example, there is a reference for JetBrains thread, and you can check what is the issue with Mockito argument capture, for example. The other problem is that basically the official documentation lacks some information about really cool features, and if you deep dive into Kotlin core libraries code, there are much more intense stuff there, like tail recursion and things like this, but it's not well documented yet. And also the community is not big around Kotlin, so obviously because it's just Java, everything what is present in Java you will be able to do that and find it in Stack Overflow and whatever. But for if you need help with Kotlin syntax or Kotlin libraries and Kotlin specific stuff, it will be harder to find. And obviously the biggest issue with that is if a company starts to use it, everybody has to learn it, and it's not a fast process. These are the references. There are a lot of videos actually, because a lot of tech talks are going on about Kotlin, and I wouldn't be surprised if this language will be a big hit after it gets released. Also there is a book now, and official blog and stuff like that. And thank you very much for listening. If there are any questions, I'm happy to answer.
One question is, it has a similar syntax to Swift and also to Go, and Android is like Google stuff, then why not Go? Is the language.
Well, actually Kotlin is not supported by Google by any means. It's developed by JetBrains, and they use it for implementing, for example, the IntelliJ platform, which Android Studio is built upon, and it has great IntelliJ and Android Studio support.
That was my second question, thank you.
But yeah, refactoring and stuff, it's really powerful already. But Google didn't say anything about their plans for Android. But I would be surprised if it was not some GVM language, because of the slow progress of new Android devices. So they can't really decide that Go is the supported language from now on, because the old devices couldn't support that.
I mean, it's just syntax. I mean, fun or funds, it's almost the same. It seems the same.
Maybe. I don't really know Go, but syntax is the same, but Go is not a GVM language.
Yeah, it's not. I
guess.
see.
Yeah. So that's why I think.
Yeah.
But it's not officially supported by Google.
Why is this project advantageous to JetBrains?
All of the developers say that developers' job is to read the code 80% of the time, write the code only 20%, and they thought Java is really hard to read and use, and they can code much faster in Kotlin. That's why they built the language according to them.
Excuse me for the second one. How is this relevant to Skyscanner?
Well, hopefully it will be relevant for us, but right now only I experimented with the Kotlin language and the features, but it's really promising for Android, and I think it can accelerate actual development, both for writing code and both for revising code.
Any benchmarks?
Yeah, actually, I think you can find some benchmarks in the reference document of Jake Wharton, and also there are some benchmarks from the Kotlin developer guys in their GitHub repository, I think.
TLDR?
It's slower than Java because of the core library features, So basically it's a JVM language, and they want to create as close to Java's JVM bytecode as possible. But to use these cool features like filter and stuff like that, you are going through the Kotlin core, where they implemented these features, and they are slower. But if you just use the basic stuff and not this magic, it should be the same as Java, because it actually compiles to the very same bytecode. So if you don't use the Kotlin core functionality, it should be as fast, or only minimal performance penalties.
Is Java fully compatible with Kotlin? I mean, if I just copy and paste Java code into Kotlin compiler, will it be able to compile it?
No. Actually, Kotlin compiler compiles Kotlin code into Java bytecode, and Java compiler compiles Java into Java bytecode, but they are 100% interoperable, so you can call these Java bytecodes through each other. Thank you very much.
So, our last speaker for today is Peter from Prezi. He is actually my teammate, and he does the exact opposite of what I'm doing. He develops for Windows, and he will tell you about some async.NET.
Hey, hi everyone. Okay, my computer is one of its kind, so last time it blinked like, I don't know, really badly, so almost 2 people got an epileptic shock, and the Visual Studio just killed the projector one time, so it just blew up, and now it turned out that I can't even show my Prezi from here, so yeah, at least we can do this in a very 21st century style, but I think it will work. And sorry, but I can't really do my live demos because it's like the 3rd computer I will make totally crap, so yeah. Okay, and I don't think that the clicker will work, or will it? It will, with PDF files? Cool. At least I learned something today. I think most of us will agree if I just say click and you just press the next button, it will work absolutely well. No, I think I broke that too.
I can be the clicker.
Cool. Then. Okay, so, hey everyone, I'm Peter Bardos and I'm a software engineer at Prezi. I'll be really fast because a lot of things happened. And before I came to Prezi, I really had to deal with parallelism, and it's mainly an overview I did for myself, and now I share with you guys because I love you and I don't know who you are, but you will see a bunch of slides from me, or frames or something like that. I will speak about the evolution of parallelism and asynchronicity in the .NET framework, and as you will see, there's a lot to cover, so I will speak pretty fast. And yeah, I'm kind of nervous now, so I will speak really, really fast. And click. Cool. Okay, so the short overview is I will speak about threads, thread pool, parallel, and p-linku. That's from the parallelism side, and I will be speaking about begin and async pattern and even-based async pattern and all those asynchronity patterns. And then I will speak about task parallel library, which is the great new feature with the async await, which is the collision of these two words, and it's pretty cool. So, click. Okay, parallelism versus asynchronity. It's, I speak with a lot of people, and they really think parallelism and asynchronity is the same thing, or they are just connected, and yeah, they're right, they are connected, but they're not the same thing, because when you deal with parallelism, you basically want to do a lot of things, and you just want to do a bunch of things at one time. So you use a lot of threads usually. And when you want to deal with asynchronicity, you just know that you want some calculations or some, I don't know, file reads or something like that, and you want it back some point of time. Not necessarily now, but some point of time, and you don't want to block your thread. And that's why you need asynchronicity. Okay, so how parallelism is even possible? Because if you have a CPU with just one cores, then parallelism is something which sounds pretty weird, because you just have one core. How can you do a lot of things at one time? And you can do it by using threads and by the help of your operation system or kernel scheduler. I know all of you learned about schedulers at the university, and I'm absolutely sure all of you have forgotten most of the things. And it's cool because I did as well. I just do a slide so you can see how clever I am, but I'm not. There's just a slide about it. So the next one is about threads. Click. And thread is just the smallest sequence of program instructions. All that Wikipedia stuff, but I absolutely think that you know what a thread is. So I will speak about parallelity. I will speak about preemptive scheduling. So preemptive scheduling is basically when your CPU lets one of your thread work, and after it decides, hey, this thread just worked a lot enough, so I give that CPU time to another thread, and then that other thread starts to work. Basically, it's just a simple queue. It has priorities. Even in 89, one Unix book wrote that, hey, it works exactly the same in Unix. Just Windows, take one step, because it has preemptive scheduling not on processes but on tasks. But I think Unix does it exactly the same way now, because they have graphical interfaces and that kind of stuff. So, okay, what is a .NET thread? How can you just deal with it? You can do. I can do that, or that household thing.
That should work.
Yeah, cool. Okay, you can do a new thread, just write new thread, and you just put new parameterized thread start, and just give a delegate to it, and you just then type start, and you just give the some input. That's why you need parameterized start. Okay, but what really matters is thread has a lot of interesting properties. For example, it has a priority, and it can be high and low and that kind of stuff. And it's just how often the scheduler needs to give runtime to this thread. But it has other properties. It can be a background thread and it can be a foreground thread. And if you have a main method and you are at the end of your main method, so your application will exit, but you have a thread that's running, and if thread is a foreground thread, then your application won't exit because that foreground thread has to run. But if you have a background thread, then your application will just exit, and you will have a lot more computing power. Okay, the next step was the thread pool. Thread pool is basically a managed environment for creating threads and for dealing with your own work, because if you think about it, you just don't want to create new threads every time you just want to process something. So you can just give it to a thread pool. It will deal with all the creational stuff and all the management stuff. So it's a pretty easy way to deal with parallelism. The downside of that is some things you just simply can't do with thread pool, because thread pool uses a hill climbing algorithm. So the more threads you need, it will give you the less, because if you have a lot of threads and they are blocked, because I don't know why, because they are just blocked, then the CPU is not really working a lot, and the thread pool really wants your CPU to work. It's wanting to maximize the throughput. So if you just create a 4 cycle and want to create 1,000 threads, then it won't create 1,000 threads. It just creates one thread, and after a second it creates another thread, and after another second it just creates another thread, because it hopes that one thread will complete and it's just give this thread to some other queued work item. So actually it would take a lot of time to instantiate 1,000 threads. Okay. But those are, pretty useful. The next thing, why would you use a thread pool, or why would you still use a thread when you can use thread pool? And this is really easy stuff. Or actually it's not, because it's from MSDN and there's a lot of, there's a lot of works on that. Yeah. But actually, if you need a foreground thread, if you need to set the priority, if you need SDA threads, if you have those, really weird scenarios when you can't use a generic thread, but you need, some special property setting of a thread, then sometimes it's better to use threads, because thread pool uses normal priority, background threads. So yeah, if you need something special, go for thread. If you can use the general one, then just go for thread pool, or even better, go for task, but I will speak about later. Okay, so there are two different kind of parallelism in C#. One is the computational parallelism, and you use threads and thread pools and all that kind of stuff, but you can use data parallelism, and one way to do this is using the parallel library, which is basically, you just easily type in parallel.forEach and just give some, that base data is just an enumerable, and it partitions that data and works on it concurrently. So yeah, that's pretty cool. It can be really fast. The only downside of it is that you need to worry about race conditions. For example, if you think that there is a condition, hey, I can use this thing, cool. If you want a condition here, like an if, and you just want to find a minimum value, then because there are a lot of threads working on it, maybe a lot of threads hit that condition at the same time, and maybe the minimum value won't be the real minimum value, just some local minimum. And to find with it, you may introduce some locking, and if you start to lock it, then maybe you just serialize all the work you did in parallel, so it can be even slower than a sequential querying of your data. So yeah, the other way to do this is everyone likes Linku, at least those people who know what it is and who use it, and uses .NET or Uno or that kind of stuff. And if you just use one little phrase, which is as parallel, then you can make your enumerable parallelism compatible, and you can even set the degree of parallelism. So you can deal with data parallelism really easily. And I think it's a great thing, and yeah, sometimes we just check it out and try how fast it is, because I don't really know. But if we go back to this slide, it was all about parallelism, and what I will be talking next is the asynchronity side. So when I don't want to do a lot of things at the same time, I just want to get some answer some point in the future. So this is some really small stuff all on the top of the slide. But basically what you can see, that you just give a callback to a bagging computation, and you will call it when it finishes. So basically it's a callback based mechanism. This is an old model, it's before using tasks. So yeah, it's kind of deprecated, but it's really important, because if you think about it, if you have an answer in the future, you need to be notified. And a callback is a really good way to do that, or the other way to do that is by an event. So the other deprecated way to deal with asynchronity in .NET is to simply have an event. And you know, I think the old web client worked with this way because you just started some requests and after a while it just fired the hey, I'm finished event, and you could deal with that. Hey, that's cool, I have event args and I can use it to have the answer of the, you know, of this asynchronous method or something like that. And it's a simple way, and if you think about it, background worker does exactly the same thing. So yeah, background worker is an event-based asynchronous worker which uses, of course, threads, so it also deals with parallelism. And you can say why asynchronity is so important, and that's one really important thing. Because there are two different ways of dealing with operations, because there are computation-heavy operations and there are I/O-heavy operations. And for computation-heavy operations, you need to, you know, burn the power of your CPU and make the whole room hot and that kind of stuff. So yeah, you need a lot of computations. But for I/O operations, you just basically put some, I don't know, put some structure in the header of your of the buffer of your Winchester and that kind of stuff, and the hardware will deal with all this and it will call you back. So it's asynchronous on a kernel level. So why wouldn't you handle it in an asynchronous way in your in the .NET framework or in the language you are using? So the next big step was tasks, because using tasks, it's kind of similar to the asynchronous callback stuff, but you can use continuations and it's really good for computation-heavy stuff. But what you really need to understand is when you just type test.run, then a new thread pop up and starts to work, and all those things works in a new thread. And when you continue with nice one, then it will work still on the new thread. So, for example, you are using the main thread, and after a while you just start to use another thread, but it will not block. It won't block you. You can just go on with your application, and when it finishes, this callback will call. And this is the continuation. You see that you just write down that, hey, I want this new thread to do something, and then you can write down that, hey, if it's got the result that I want it to do in this way. Of course, you could use callbacks, but it's just so easy to use. It supports cancellation, and it supports task scheduler settings. So, for example, you can just tell this point that you want to use it at the caller's context. So if you have some UI, you don't have to deal with dispatcher upon begin invoke and dispatcher dot begin invoke or that kind of stuff. So it's just a nice and easy way to deal with parallels. And as you see, this is a computationally heavy operation. And the last step to deal with asynchronity is using the async await. And this is basically the readability paradise for all the developers, but especially for all the .NET developers, and fortunately for all the JavaScript developers, because they have promises. And what you need to take away with you is task is a promise of future result. So task is not only come from threads. Task can come from I operations. Actually, the .NET framework, the new I/O bounded operations are written in a task supporting way. So it can give you back. For example, if you want some stuff from the web and you just make a web request, then you can just want a task result, and when you have a task result, then you can write await before it. And this await basically means that, hey, I know I have a message pump, and I know I don't want to block the main thread, but at that point of time, I know that something starts to work. I know that till it's not finishes its work, I don't really need this resource. I don't really want to go over. So I just give back the control to the message pump, and I can just work on any other stuff. So the UI won't block. And after a while, when the crazy compute async just returns its value, it just starts to work from this point. So why it's really important? It's really important because it's not about parallelism. You don't have a bunch of code at the same time, because if you just have, for example, an HTTP request, then you won't even have another .NET thread, because the operation system is dealing with it. The network card will deal with it, but you will not have another thread till the answer comes back from the hardware. So actually you can just have a bunch of await. Actually, you could have seen it if I could have shown it to you, because I had some live demos, and that's why I'm talking a lot now, because I couldn't show it to you guys. But you can write methods in a synchronous way, just because you can use await word, and even those are asynchronous. So you don't really block your main thread, and in some scenarios you won't really use the resource of the .NET framework or the computational, all of the threads of the .NET framework, because you could use the kernel instead, or the hardware for I/O operations. Yeah, yeah, that's it, guys. Sorry I can't really show you the demos, and those are the interesting ones. So thank you, and you can see all the demos here, because I just uploaded it to GitHub, and you can watch it and imagine that I speak with my tender voice and saying some nice things to you. Okay, and of course there are a bunch of references. You can just read them. Hopefully be as smart as a lot of people. Okay, do you have any questions? Besides the fact why it does not work, because I still don't know that. Okay, I see you are Android developers and you are iOS developers, and there's one guy there in the dark, so.
Have you checked rx.net?
Yes, of course, we are using it for streams of events and streams of data, and yeah, I was gonna talk about that, but actually there are a lot of stuff to talk about and to show, so it couldn't really fit. And I think, in a way, rx.net is one level higher than this kind of stuff, because this is pretty basic stuff, how you can deal with parallels and asynchronicity, and it's more like, composing those streams of events and streams of stuff, so yeah. But yeah, it's definitely worth checking out.
So what I wanted to ask actually is that, would you prefer this async await, which is a bit lightweight solution, or the rx.net way, when you just using observable, returning values all the time, and everything is observable and stuff like that?
Yeah, it's interesting, because I have to use this, I have to use the other as well in my projects, and in a way I prefer this a little bit better, because it's just easier to understand, it's easier to deal with. Rx can be pretty complicated, and if you use it a lot of times, I think Agnes could talk about that, then Rx could be really, really, I don't know, hard to deal with some problems, so yeah. I think one of the guys even asked Eric Meyer, the head of RX, about some problems we had, and he said that, yeah, that's, interesting. Go to the next slide. Something like that, yeah. So it's definitely easier. Okay. Cool.
Thank you, Peter. You are awesome, and you are actually a great presenter. So, thank you guys for coming, and we will upload the videos and everything else to the Meetup page and our GitHub page. And we should go together right away to Anker Club, where we reserve some tables. So let's just grab some beers together. And a big thank you for Skyscanner and the craft beers, of course. You are awesome too.
You're welcome, and sorry for this tech problem.
It happens.
Yeah.
It's definitely Skyscanner fault. I mean, we don't,
Yeah, it wasn't crazy at all.
we don't do presentation all the day, so we need some practice there.
Okay, thank you very much.
Thank you very much.